Hi guys, welcome to Geography series. Okay, and in previous class we have talked about convergence and divergence boundaries as part of plate tectonics. Okay, and there is another one left out. It is called as transform boundary. Okay, let's look into it. Transform boundary also called as transform boundary also called as conservative boundary. Why conservative boundary? Because during a transform plate movement, there is no creation or destruction of crust or plate. Okay, but when it comes to convergence boundary, there is destruction of plate, and in divergence boundary, there is creation of new crust. Okay, but in during a transform movement, there is no creation or destruction of the crust, so it is called as conservative. Okay, um, what really happens during a transform fault? A transform fault, there is no major creations or destructions happen during a transform fault. Okay, here the two plates slide past each other in a horizontal manner. These are two plates, they slide past each other. Okay, due to rising magma, when it hits, these two plates slide past each other. Okay, here there is a plate and another plate. Okay, due to continuous hitting of the magma, the plates slide past each other. Okay, that means what happens? One will go down and other will come up like this. Okay, this is the initial position. Due to continuous hitting in a transform fault, what happens? There is a strike and slip movement. Strike and slip, thus striking of the magma and slipping of the plates. Okay, that's all. Nothing happens during a transform boundary movement. Okay, we can observe earthquakes in a transform fault or in a transform plane. Okay, we can observe earthquakes. The best example would be Pacific plate and North American plate. There is a transform fault along these two plates, Pacific plate and North American plate. Okay, the west part of North American plate. That's why we can frequently see earthquakes in California. Okay, and the fault present at California is called as San Andreas fault. Even we had a movie called San Andreas. It is called as San Andreas fault. Okay, so that's all about plate tectonics. We have discussed convergence, divergence, and transform boundary. Okay, and there is another small topic in your physical geography textbook, class 11. It is about movement of Indian plate. Okay, what does Indian plate consist of? Indian plate consists of our peninsular India. I hope you guys know what peninsula is, and continental part of Australia. Okay, it contains peninsular India and continental part of Australia. Indian plate consists of. Um, the Indian plate, we have discussed it once. It is a whole unit mass with Africa, Australia, and India and Antarctica. They are together, and somewhere around 200 to 300 million years ago, our Indian subcontinent was as south as 50 degrees south latitude. Okay, and it started its northward journey, that is towards Eurasian plate, somewhere around 70 million years ago. Okay, it was mentioned the number of years that was mentioned in your textbook. It's not important, but just look into it. That's all. Okay, yeah, where are we? 70 million years ago, our Indian plate started drifting towards northward. Okay, what were the boundaries of our Indian plate? The north boundary extends up to Himalayan subduction zone. Okay, Himalayan subduction zone. Himalayan does not, it is not confined to only our, Jammu and Kashmir, Uttarakhand, or along Arunachal Pradesh. Himalayas were beyond that. Beyond even Jammu Kashmir, also we have Himalayas. That means we call them as Himalayas in India. That's all. But the fold mountain formation was so huge. It extends up to, you know, beyond Tibet and up to Kanlanshan. Kanlanshan, okay, that was north of Jammu and Kashmir. Please locate it in your map, okay. Himalayas also consist of our Indian Himalayas, the Tibetan Himalayas, and Kanlanshan, and up to, it extends even into some part of Afghanistan also, okay. Yeah, the Himalayan subduction zone. Subduction zone means we have talked that the yeah, Indian plate is denser than Eurasian plate, and Eurasian plate is subducting into interior of the earth, and it at this while subducting, the depositions of Tethys were formed as series of folded mountains, and we call them as Himalayas. Okay, that subduction, the Himalayan subduction part is called as, yeah, I mean, it is the northward boundary. Okay, east boundary. Eastwards, Indian plate extends from Rakinyoma Mountains or Arakanyoma. It is present in Myanmar, Arakanyoma Mountains, up to Arakanyoma Mountains to Java. Okay, up to from the eastward boundary is from Rakinyoma or Arakanyoma to up to Java. Okay, and next western boundary extends up to Kirtar Mountains. Kirtar Mountains are present in Pakistan. Locate all these places in your map, okay? It helps you. The western boundary extends up to Kirtar Mountains. Kirtar Mountains is located, I think, north of Karachi. Located on your map up to Pakistan, and extends up to, Red Sea and the Chagos Archipelago. Chagos Archipelago will be on east of the eastern coast of Africa. Okay, south to India below the equator. Chagos Archipelago is located. The western boundary is extends from Kirtar Mountains and extends into Red Sea, and from Red Sea it extends up to Chagos Archipelago. Okay, if a group of islands were called as archipelago. That's all. It's called as Chagos Archipelago. It's located on the off the eastern coast of Africa. Off the eastern coast, that is away from the eastern coast of Africa. Okay, yeah, and south. The southern boundary of Indian plate is once part of Antarctica, while drifting towards north, and Antarctica is drifting towards south. There is divergence. We can observe divergence here. Okay, where due to northward movement of the Indian plate and southward movement of the Antarctican plate, we can see divergence here. And due to this divergence, we can see a series of ocean ridges, and it is nothing but a series of ocean ridge on the north side of Antarctica in a west to east direction. West to east direction means in a horizontal manner. Okay. North to south directions means in a vertical manner. Okay. In west to east direction, on the north of Antarctica, or like slightly southern to Australian coast, we can see a series of ridges. It is called as Southeast Indian Ridge. Okay, which was formed. The southern boundary extends up to Southeast Indian Ridge. Okay, and somewhere around 70 million years ago, the northward journey of India has been started. Okay, and during that northward movement, the peculiar or a special or grand event that occurred was the formation of Deccan Traps. We have already discussed about Deccan Traps while I am saying about continent-continent convergence, the convergence between Indian and Eurasian plate, while Indian plate is moving towards the Eurasian plate. Okay, this is Indian plate and this is Eurasian plate. They are moving towards each other. During this movement, the rising magma developed cracks in the Indian plate and oozed out as lava, and that lava reached the surface, and eventually the lava got solidified and formed as traps as thick as from 50 meters to certain 30 kilometers of thickness, and it is situated in Maharashtra and Madhya Pradesh plateau region, and it arranges in Maharashtra Madhya Pradesh plateau. Okay, these are called as Deccan Traps. Okay, that's all about movement of the Indian plate. Yeah. Uh, with this, we have completed formation of oceans and continents. Yeah, and next important topic would be interior of the Earth. Okay. Yeah. Uh, yeah. Interior of the Earth, that is layering of the Earth below the surface. We have to know about interior of Earth. We have two types of evidences. They are direct and indirect. First, we will look into direct. Yeah. We all know that no one can travel inside of the Earth certain beyond point, because due to the high temperatures, humans cannot sustain. Even if we send certain machineries also, um, those machines cannot sustain that high temperatures and high pressures. Okay, that's why one cannot travel into deeper parts of the Earth. Recently, I think you have heard about the news. Not recently, I think it's way back around one and a half year back. There is a expedition in happened in United States of America where some private company had sent you know passengers into deep sea as part of recreational activity in a globe shaped vehicle. They have sent certain some passengers as a recreation activity into deeper parts of the ocean. Okay, but unfortunately that the activity got mishap, and there is an accident happened, and all of them died. Why? As we move into deeper parts of the earth, even the ocean also is way below the continental part. As we move down, due to that immense pressure of water, it applies very immense pressure on the surfaces below, surfaces or any materials below it. Due to that immense pressure, that globe shaped vehicle got crushed, and eventually the people got died. Okay. um, I am talking about oceans. Imagine the pressure that is interior of the, that is way below the ocean, that is inside. I mean, if you dig the ocean bed and go to deeper part of that, imagine the pressure over there. Okay, so no one, a human can't reach over there. Even if you send any machines, it is highly impossible to again to retrieve that machine or get back that machine. Yeah, so we depend on certain direct sources to know about the interior part of that. The first one would be mining. Okay. uh, Mining activities. During mining activities, people go up to 3 to 4 kilometers interior of the earth, and the sources or the materials collected at that at 3 to 4 kilometers gives the evidence about the materials inside the earth. Okay, it is one direct evidence. Another direct evidence would be deep sea drilling projects. Deep sea drilling projects. During the deep sea drilling projects, the materials obtained also acts as a source for the source to know about interior parts of the earth. Another one is volcanoes. Whenever the magma oozes out of a volcano, the interior portions of the materials present in the interior portions of the earth come onto surface of the earth, and they act as another direct sources to know about the interior of the earth. Okay, this one. And yeah, these three are the direct sources. Okay, and yeah, let's go to indirect source. First one would be meteors. Okay, meteors are not part of the earth, but they come from outer outer part of the universe, not universe, outer part of the earth's atmosphere, that is from the universe. And if there are any earth like materials comes from the space, scientists collect them and study them, and they based upon its density and the materials consisted in it, uh, they based upon the materials consisted in it, scientists can know about the interior of the earth. It acts as indirect source because it is not directly from the part of the earth. So it is indirect. And another one would be gravity anomaly. Yeah, gravity anomaly. Even while I have already told you that Earth was spherical in shape, due to its continuous rotation, it is bulged at the equator and flattened at the poles. Flattened at the poles and bulged at the equator. Okay. Due to this, the polar region is much more closer towards the center, and equatorial regions are far away from the center. So we can experience different types of gravitational attractions at different parts of the earth. At polar regions, we can experience maximum gravitational attraction, and at equatorial region, or at the lower latitudinal region, we can experience low gravitational attraction. So there is a difference in the gravitational attractions at the different parts of the earth. This difference is nothing but gravitational anomaly. Okay, so yeah, so at the different parts of that we can experience different gravitational attraction. Based upon that, scientists can come to conclusions about the density of the materials present closer to that part of the earth. Okay, for example, at poles we can experience maximum amount of gravitational attractions because why, it is closer to the center of the earth, and it is first thing. Secondly, why more gravitational attraction? Because at the center of the earth there is very dense material present at the center of the earth. Due to this dense material, we can experience maximum gravitational attraction at the poles. So it is one of the conclusion scientists have okay, like concluded this. At the center of that, there is very huge dense material. Likewise, based upon the gravitational attractions, or the gravitational attractions or gravitational values at different parts of the earth, scientists come to certain conclusions about the materials present inside the earth. Yes. Second one would be magnetic field. Sorry, magnetism. Okay. What is magnetism? Different elements or different magnetic field. For example, you take iron, it shows maximum magnetic field due to magnetic properties present in it. Likewise, uh, the materials collected from the different sources show different sort of magnetic properties, and based upon that, scientists can arrange. If if any deeper part of the earth shows maximum magnetic field, we can say that yes, at certain depth there are high density materials, and as we move upwards there are less denser materials due to magnetic difference in the magnetic properties. Likewise, they come to certain conclusions. You remember that indirect sources consist of meteors, gravity anomaly, magnetism, and last one was seismic activity. It is nothing but earthquakes. By far, this is the most profound and most trusted evidence to know about the interior part of the earth. What is the most trusted evidence for the to know about interior part of the earth? It is seismic activity. That is nothing but earthquakes. Okay. And it comes under indirect sources, not direct sources, indirect sources. Okay. Yeah. So to know about interior of the earth, first we should learn about earthquakes and what really happens inside of the earth during earthquakes. Yeah. So what is earthquake? You know, when there is a sudden release of energy, the energy travels in certain medium in form of waves. Likewise, if I clap, this is a medium. This room has certain medium. That is, it has air. Air is the most, you know, the most part of the room consists of air. Okay, right? If I clap, the energy is released in the form of waves and it travels in the entire room. Likewise, earthquake is also a release of energy. Okay, a release of energy, and that energy travels in form of the waves in the entire part of the interior of the earth and it reaches surface. Okay, how energy is released? We will talk about how energy is released. So, by far you are clear, right? Earthquake is nothing but a earthquake is nothing but the release of energy inside the earth, and release of energy travels in the form of waves, and these waves hit the surface of the earth and produce quakes. Okay, they shook that part. Okay, how energy is released? We will talk about it. Um, this energy releases along a fault. Fault is nothing but we have studied that the rising magma hits the crustal part or lithospheric part, remember it as lithospheric part, and develops cracks. Okay, develops cracks, and the release of energy inside of the earth travels through these faults and reach the surface of the earth. Okay. Yes, when the magma hits the crustal part, uh, the rocks inside it, there are rocks inside the crustal part. When the magma continuously hits that part, these rocks are there, right? They develop a certain tendency to move in opposite directions. They are bound like this due to continuous hitting of the magma in the crust, in the lithospheric part. These rocks develop tendency to move in opposite directions. Okay. Yeah, but they cannot move in opposite directions. Why? Because above these rocks there is a continental part situated above these rocks, and this continental part or crustal part per se, crustal part, it can be oceanic crust or continental crust. Okay, that crustal parts, sticks it together so that though the magma hits continuously, these rocks cannot move. Okay, why? There is a crustal part situated above it and it is sticking together the rocks. But due to eventual or due to continuous hitting of the magma for a certain period of time, the this the ability of friction, the friction in the sense, if the crustal part is holding it together, it cannot move like this because due to high amount of friction, it is the crustal portion is like producing high pressure on these rocks. Due to this high pressure, if friction is developed, if there is more friction, if like say, see, imagine these two are certain particles. If there is high friction between those two particles, they cannot move. Why there is high friction? you keep your hands and just squeeze them like this and try to move one hand or other upwards. It is difficult to move because why? Due to the pressure you are exerting on these hands, a friction is developed in between them, and this friction is helping to stick them together. Okay, that's why it is somewhat difficult to move this upwards or downwards. Or yeah, this is one part. Another thing is you just just stick them together freely and move it. These can move up and down very easily without any difficulty. Why? Because of less friction. There is no pressure that is holding them together. Okay, due to less friction. Likewise, these rocks are pressurized by the upper crustal portion. Due to this pressure, a friction is developed and this friction is sticking them together. Yeah. Okay, I have said that the magma is continuously hitting. Due to continuous hitting of the magma, the ability of the friction to hold them together breaks at certain point. Okay, it breaks at certain point and these rocks move in opposite direction. When these rocks move in opposite direction, there is sudden release of energy. Okay, this sudden release of energy forms in the form of waves in the interior part of the earth and reach the surface, and it is called as earthquake. Okay, when these rocks move apart and shook the part of the earth up to where the waves can travel, that part of the earth shakes, so it is called as earthquake. Okay, it makes sense to you, right? Due to release of energy. Yeah, yeah. And this is first one. Sorry. uh, Earthquake, why it happens? Due to release of energy, and energy travels in the form of waves. It is first thing. You are clear about release of energy, why energy gets released. You are clear, right? Make sure you watch it again, so that there was no confusion. you know uh, See, regarding physical geography, you have to listen with utmost attention because there are many logics in this, and it's like a thriller movie. you know Once you learn one part, another part unfolds. Once you learn that part, another one unfolds. Okay, that's right. So, release of energy travels in the form of waves. Second thing is, it is a natural event. We all know that. Third thing, it happens in the lithospheric part of the earth. Okay, all earthquakes takes place in the lithospheric part of the earth. Okay, what is lithosphere? Crust plus upper portion of the mantle is called as lithosphere, and all the earthquakes happen in lithospheric part of the earth. Why? uh, because the rising magma hits the lithosphere continuously. Okay, that's why the quakes happen in the lithospheric part of the earth. Okay, we learned that the due to continuous hitting of the magma, the rocks move apart and releases energy. The point where the energy is released called as hypocenter or focus. It is present interior of the earth. Okay, the release of energy, where the release of energy happened inside of the earth, it is called as focus or hypocenter. Okay, and also we learned that the energy travels in the form of the waves in the in the interior of the earth and reaches the surface. Okay, and the point on the surface which experience the earthquakes for the first time is called as epicenter. It is present on the surface. Okay, the point on the surface of the earth which receives that energy or the waves for the first time is called as surface, sorry, epicenter. From that epicenter, the waves travel on the surface of the earth and destroys the materials present on the in the way between. Okay, so hypocenter and epicenter. Hypocenter present in the interior of the earth, epicenter present on the surface of the earth. Okay, yeah. And next, we said that the energy was travels in the form of the waves. It is nothing but seismic waves. seismic waves. Okay, nothing but seismic waves. These seismic waves are of two types. They are body waves and surface waves. Body waves and surface waves. Body waves travel faster than the surface waves. Okay, body waves are present in the interior of the earth. They travel faster, and when they reach the surface, they are called as surface waves. Okay, body waves travel inside the earth, and when they reach the surface, they are called as surface waves. Okay, and again, these body waves are divided into two. They are primary, denoted as P waves, and secondary, denoted as S waves. And surface waves are also divided into two types based upon the movement of the material. Okay, if the material moves in an elliptical way while these waves hit the materials travel or move in certain direction or in a certain shape. And okay, if they move elliptically, it is called as Rayleigh waves, wherein the materials move elliptically. If the materials move in a zigzag way, it is called as love waves. Okay, yeah. Surface waves are more destructive compared to body waves. Okay, yeah. Now let's look into this details about these waves. First one, primary waves or P waves. They are called as longitudinal waves. Okay, they are called as longitudinal waves. They can travel in solids, liquids, and gases. Okay, P waves are similar to sound waves. It is another property of P waves. P waves are longitudinal in nature. They can travel in solids, liquids, and gases, and they are similar to sound waves. Fourth one is you know while they travel to certain material, certain rocks inside the earth P waves, they change the density of that material. Okay, because why? Because they are longitudinal. So longitudinal waves travel like this. Okay, if this is direction of propagation of the wave, like uh, this arrow mark is direction of the propagation of the wave. That is the way, I mean, the direction which the wave is traveling. Okay, see, longitudinal and what we are saying, yes, these P waves, right, when they travel through certain material, they change the density of that material. Why? Because see here a compression is happening, and again here release, and again compress, and again release. Okay, while traveling through that material, these P waves are compressing that material and releasing them, compressing them, releasing them, compressing them, releasing them. Due to this continuous compression and release, the density of the material changes. Okay, that is another one. What? They change density of the material through which they pass. Okay, yeah. And another one is they are faster than S waves. Faster than S waves. And while P waves are traveling to certain materials, there is I said that there is a compression and release, and this compression release happens along the direction of the propagation of the wave. If the wave travels horizontally, the materials also compress and releases in a horizontal way. Okay. And second one is they are faster in denser medium. In other words, we can say that as the density of the material increases, the speed of P waves decreases. Sorry. Uh, how can we say it? Yeah, density of the material as the density of the material increases, speed of the P waves increases. That means they travel faster in solid medium compared to liquid and gaseous mediums. Okay, that is P waves. Another one is S waves. They are called as transverse waves. Travel only in solid. It is very much important. Please do remember it. They travel only in solid, solid medium only. As well as travel only in solid medium, they are called as transverse waves. Yeah. And third important thing is the movement of the material through which the S wave passes is perpendicular to the direction of the propagation of the wave. Okay. See, we said that they are transverse waves. That means they travel. And how the material movement would be? It is a direction of the propagation of the wave. The direction which the wave moves uh, is this. Okay. And how the material moves perpendicular to this propagation. That is material moves either like this or like this. It is movement of the material. Direction of wave. So we can say that the movement of the material through which the S waves passes is perpendicular to the direction of the propagation of the wave. Okay. And another thing is the materials through which the S wave passes, they create crusts and troughs due to crust and troughs means nothing but as we said that uh, it wave is S waves travel in a transverse way transversely. This is called as crust and this is called as trough. So as they move like this, they also create those impressions on the materials they pass through. That is, they create crust and trough in the materials they pass through. S waves. Okay, S waves are also called as transverse waves, and they travel only in solid, and they cause crusts and troughs in the materials they pass. Yes, this is about earthquake waves. Okay, once these waves travel into P and S waves travels in the interior of the earth, they reach the surface. That is if epicenter from the focus, they reach to the epicenter. Epicenter is the point on the surface which experiences these waves for the first time, and it is always perpendicular to the focus. Okay, and it is nearest to the focus also. Okay, what epicenter is perpendicular to the focus, epicenter is nearest to the focus. Yes. And another thing is, when once these waves reaches the surface, uh, they travel in different directions and cause displacement of the particles while they are traveling. Displacement of the particle means the movement of the particle from the one point to another point. They displace that particle. If they travel through car, they displace that car from that position to another position. Okay. And based upon the movement of like direction of the material, direction traveled by the material, these surface waves are divided into railing waves, in which the material travels in an elliptical way, and low waves where the material travels in a zigzag way. It is surface waves. Surface waves are more destructive. Okay. Yes, this is about earthquakes. uh, and yeah, okay, this is about earthquakes. Hmm. How this earthquakes gives evidence about the interior of the earth. For this we have to learn shadow zone, the concept called shadow zone of P and S waves. Okay, you draw your diagrams in a in a neat manner. I'm very bad at drawing, please don't mind it. I'm working on it, but I couldn't. Okay. We we previously, like, we learned that from the focus these P and S waves traveling inside the earth. Okay, from focus, this is focus. Okay. Yeah. And this is like center of the earth, and this is 180 degrees. Like, earth is we say near spherical, or spherical is one of the form of circle, right? From the center if you make an arc 180 and another arc 360, so it is 180. Okay. And yeah, what does shadow zone of P and S waves say? From the focus, when the P waves travel inside the earth, they travel, even not only P waves, S waves also, they travel in a curved path, not in a straight line, curved path. Why curved path? Because of the refraction. What is difference between reflection and refraction? Reflection happens in the same medium. Like, in this room, if I project a light in this room, it is the same medium in the entire room. Okay, this it is same medium. It consists of same amount of material in the each corner of the room. Okay, if I project a light onto a surface, the light reflects back to me. Okay, it bounces back to me. It is called as reflection. It happens in the same medium. What is refraction? Like, if it is a a boundary, and above this boundary there is air, and below this there is water. Okay, whenever I project a light inside to the water, the density changes. Okay, and the light refracts from its direction. I project a light in this direction. Okay, but due to difference in the density, the light traveled in this direction. Okay, can you all see it? Okay, I projected the light in this direction from the surface, from the air, and when the light traveled inside the water, the density changes and the light ray got retracted and deviated from its initial direction. It is called as refraction. So, due to different different varied densities inside the earth, these p waves and s waves traveled in a curved path. So that is, when they travel from one medium to another medium, their path deflected. Okay, and they traveled in a curved path. Okay, up to 105 degrees, they traveled in a curved path like this. 105 degree, 105 degree. Oh, sorry. 105 degree. Up to 105 degree, the P and S waves traveled in a curved path. Okay, beyond 105 degrees, up to 145 degrees. Okay, uh, these P waves showed shadow zone. Okay, you understood my point. Up to from 105 degrees up to 145 degrees, these P waves have shown shadow zone. That is, beyond 105 degrees, due to sudden change in the density, these P waves got slowed down. They deflected in such a way that they again appeared at 145 degree. Okay, and from here onwards again they travel. So from 105 to 145 degree, that here 145 degree, P waves have shown shadow zone. That is, they disappeared. Okay, they disappeared in that zone. Shadow zone means from 105 to 145 we cannot measure or we cannot see P waves traveling in that zone. They got deflected and again appeared after 145 degrees. Okay. Okay, what does it indicate? We will learn afterwards. And coming to S waves, after 105 degree, there is complete shadow zone for S waves. We cannot see S waves beyond 145 degrees. See, sorry, 105 degree. After 105 degree, due to change in the density of the medium, S waves got disappeared. They cannot travel through after 105 degrees because of change in the density of the medium. S waves got disappeared after 105 degrees. Okay, this is called shadow zone of P and S waves. So, what does it say about interior of the Earth? Like, yeah, what does shadow zone of P and S waves says about interior of the Earth? We learned that P waves travel faster in denser medium compared to S waves, and also P waves can travel in solid, liquid, and gases, um, and P waves travel only in solid. Okay, so based upon this shadow zone and traveling of the P and S waves inside the Earth, scientists have came to a conclusion regarding the interior of the Earth. Okay, how these P and S waves are recorded? These P and S waves are recorded on a seismogram. There is a device called a seismogram. Whenever sudden release of energy happened inside the Earth, um, like these seismograms record the earthquakes. First, P waves appear. After the P waves, S waves appear. After S waves, surface waves appear on a seismogram. Okay. Yeah. So, what does this P and S waves and shadow zone says about the interior of the Earth? That's what actual matters. And yeah, give me a minute. from focus. Okay, from the focus, that is from the lithospheric part, these p waves and s waves travel very seamlessly, indicating that is a solid part. So uh, so uh, the analysis says that seismic waves in traveled the focus, we said that the focus point will be present in lithosphere because the quake happens in lithospheric part. Lithosphere is nothing but the crustal part, crust and the upper portion of the mantle. Okay, so in crustal part, these p waves and s waves have traveled, and during the travel scientists have noticed that p waves have traveled faster, or P waves or S waves, P and S waves have traveled faster in faster in oceanic part rather than in continental part, depicting that oceanic crust is much denser than the continental crust. Okay. First thing, what did they discovered? Oceanic crust is much denser than the continental crust. Why? P and S waves traveled faster in continental crust. Sorry, oceanic crust, indicating it is more dense. Okay, yeah. After the crust, okay, that is after crustal portion, that is around 35 kilometers. Uh, After the crust, the speed of seismic waves increased. After the crust, it will be time taking if I write everything. After the crust, uh, the speed of the seismic waves increased up till 100 kilometers, indicating upper solid mantle. Okay, after the crustal portion, that is from 35 kilometers up to 100 kilometers, the speed of the P and S waves have increased, indicating an upper solid mantle. Okay, beyond 100 kilometers, okay, beyond 100 kilometers up to 200 kilometers, up to 200 kilometers, beyond, after that 100 kilometers up to 200 kilometers, P and S waves slowed down, indicating presence of asthenosphere. Okay, okay, and beyond 200 kilometers, that is after the 200 kilometers, um, you know, sorry, up to 600 kilometers. It is, sorry, up to 600 kilometers, P and S were slowed down, indicating that beyond 100 kilometers, that is after the 100 kilometers, that is after upper solid mantle part, from that 100 kilometers to 600 kilometers, uh, P and S were slowed down, indicating a fluid form called as asthenosphere. Okay, and yeah, beyond 600 kilometers, beyond 600 kilometers, that is after 600 kilometers, P and S waves increased the speed, indicating lower solid mantle. Beyond 600 kilometers, there is lower solid mantle because the speed of the beyond six after 600 kilometers, speed of P and S waves increase, indicating the lower solid mantle. Okay, at 105 degree, we learned in the shadow zone of P and S waves, like right, at 105 degrees, S waves disappeared. and P waves slowed down. That is after 105 degrees, or else you can also write that like after 2900 kilometers. So from 600 to 2900, P and S waves travel very fast, indicating that from 600 to 2900 kilometers, like uh, from 600 to 2900 kilometers, it is a lower solid mantle portion, and P and S waves travel faster after 2900 kilometers. That is, at that 2900 kilometers, it is 105 degrees, and after that 2900 kilometers, S waves, like S waves disappeared and P waves slowed down. Okay, P waves slowed down, indicating that is it is less denser material, called as outer core. It is liquid in nature. Okay, and this slowing down of P waves continued till 5100 kilometers. That is from 2900 kilometers to 5100 kilometers. S waves, S waves disappeared after 2900 kilometers, but P waves travel, but in a much slower manner, indicating it is a liquid material. That is from 2900 to 5100. At from 5100, the speed of the P waves increased. Okay, increased rapidly, indicating beyond 5100 or beyond 145 degrees, speed of P waves increased, indicating a solid inner core. Okay, yeah, and this extends up to from 500 to 6900 kilometers from the focus. The inner core is at 6900 kilometers. Okay, and again I will explain this by showing you the shadow zones. Okay, see, from the focus, okay, that is, it is lithospheric part, crustal part. P and S waves travel faster. See, P and S waves travel faster, indicating crust is a solid. Okay, and as crust is a solid, what am I saying? Yeah, crust is solid, but oceanic crust and continental crust, the density varies, and scientists have discovered that these P and S waves travel faster in oceanic crust, which indicates that oceanic crust is more denser than the continental crust. Beyond the crust, that is crust, that is up to, this is up to 100 kilometers. Okay, beyond 100 kilometers, that is from 100 to 200 kilometers. Sorry, wait. The thickness of the crustal portion would be 35 kilometers. From 35 km to 100 km. Here, 35 km to 100 km. Speed increased. Speed of the P and S waves increased, indicating a solid upper mantle. Okay, beyond 100 kilometers, that is from 100 kilometers to 600 kilometers, there is asthenosphere. Okay, there is asthenosphere, because P and S wave speed has reduced, right? Beyond 600 kilometers, that is from 600 kilometers, uh, you know, to 2900 km. That is this. Okay, up to 2900 km. Wait. Okay, speed again increased, indicating lower solid mantle from 600 to 2900 kilometers. Um the speed of the P and S was increased again rapidly, indicating a lower solid mantle beyond 2900 kilometers. That is beyond 105 degrees. You see here, beyond 105 degrees, S waves disappeared. There is shadow zone for S waves. S waves disappeared beyond 105 degrees, indicating there is a less denser medium than the solid. As S waves cannot travel in solid, they cannot travel to further, and it stopped at 105 degrees or 2900 kilometers. And this less dense material, like this less dense material extended from 105 to 145, that is 5100 kilometers. So that is from 2900 to 5100. We have, see, look here. Once these these quakes, like these waves, entered this liquid outer core portion, they deflected and the waves disappeared. The waves disappeared here. They traveled in a very slow manner. S waves disappeared and P waves traveled in a very slow manner. See, outer core, and they got deflected like this. Again, traveling in the outer core, they got deflected like this. And once, that is after 145 degrees, that is after 5100 to 6900, there is solid. See, the P waves coming like this, entering into liquid outer core, and they're deflecting. And at 105 degrees, they have hit the solid inner core, and they traveled through this. Okay, indicating the inner core is solid in nature. That is from 5100 to 6900 kilometers. Okay, so uh, seismic waves are by far the most trusted evidence to know about the interior of the earth. I hope you understood this concept of shadow zone, concept of P and S waves, the concept of release of energy and traveling of waves inside of the earth, and the hitting the surface. Okay, now we have talked about interior of the earth. And like, I will give you the diagram of the interior of the earth in the next class. I don't have time now. And yeah, and in a quick manner, I will talk about types of earthquakes. Okay, yeah, when we go into types of earthquakes, we have tectonic earthquakes. These tectonic earthquakes are nothing but earthquakes that are traveling through this fault and hitting the surface of the earth and causing the destruction. They are called as tectonic earthquakes. Okay, another classical case of tectonic earthquakes is volcanic earthquakes. Sometimes these volcanoes are so massive in nature, they explode in such a way that they created tremors. Tremors are nothing but shocks, shocks like this. They create tremors. That is, they send immense amount of pressure into the area surrounding it. So these volcanoes explode in such a way. Certain volcanoes, we'll talk about it during volcanoes chapter, like topic. These volcanoes explode in such a way that they cause tremors in the surrounding area. They are called as volcanic earthquakes. Volcanic earthquakes are also a type of tectonic earthquake. Okay, and next, in the areas of intense mining activity, sometimes they go deeper. They drill the part of that. Due to this continuous drilling, the roof of the mine, So if this is the mine, this is the roof, and due to continuous drilling inside the earth, this roof collapses down, causing the tremors, and then passing the tremors in the area surrounding it, and it is called as collapse earthquake. Okay. um, when there is sudden explosion of any chemical or nuclear weapon, there is a ground shaking. Okay. And it is called as explosion earthquake. We have talked about tectonic earthquake, volcanic earthquake, collapse earthquake, and what ground shaking earthquake called as explosion earthquake. Okay. Another one is reservoir induced earthquake. What is reservoir induced earthquake? For dams we construct reservoirs, right? um, when this reservoir is so deep, when we dig so deep to construct that reservoir, um, suddenly that reservoir collapses and causes tremors, uh, it is called as reservoir induced earthquake. Recently China have announced the construction of a world's highest dam along on the north side of the Arunachal Pradesh. Many of the environmentalists are like they're opposing it. Why? This that part of the Arunachal Pradesh, or the part where the dam China is constructing the dam, it comes under the seismic zone. Seismic zones are nothing but they are zones of the earth where there is intense earthquakes happen. Why Arunachal Pradesh, or the area north of it, is a seismic zone? For that matter, entire northeast is a seismic zone. Why? Because at that point subductions happen. Like subductions happen because subductions happen and Himalayas grow height. This subduction goes downward, hit the plate again, and due to this continuous hitting there will be tremors passing. And due to this tremors, it is designated as a seismic zone. And if there is any minor tremor also, this reservoir can collapse. There is a chance of being collapsed, and once this reservoir collapse, it develops into a huge earthquake. Okay. It is called as reservoir induced earthquake. And again, tsunami, like tsunami is not a type of earthquake. Tsunami is consequence of earthquake. Okay. See, during while earthquake happens on the surface, what we'll experience a ground shaking, collapses of building, and displacement of certain materials, floods. Likewise, if this release of energy, like no when this epicenter, that is the point on the earth where uh, the point on the surface of the earth, which experiences these earthquakes for the first time. That is from the focus, when the waves travel, the point on surface of the earth which experiences these waves for the first time is called as epicenter. Okay. And when this epicenter is found in the ocean, then we can see tsunamis. Why? When this epicenter is found inside the ocean, um, the waves travel inside the ocean. Due to this traveling of the waves, we can see tsunamis, that is huge waves. These huge waves are called tsunamis. Okay. Tsunami is not an earthquake. These huge waves that are induced due to presence of epicenter inside the ocean are called as tsunamis. These waves are called as tsunamis, and these waves persist for a longer period than the earthquake, because due to that shaking of the ocean, these waves generate, and they travel longer distance, causing very destruction in their entire course. Yeah, these are the types of the earthquake. And so yeah, I will stop here, and in the next class I will give you the diagram of interior of the earth, and we will talk about volcanoes and formation of minerals and rocks, and then we will start geomorphology or geomorphic process. Okay. Yeah. Thank you.